Section 1.1, Angles, Degrees, and Arcs. In this section I'm going to present some basic terminology and concepts that we are going to need for the remainder of this course. There's also a couple of skills involved in this section that we will also need later on. A great amount of time is going to be spent in this course dealing with angles. And so the first question might be, well, what is an angle? From a geometric point of view, an angle is formed by rotating a ray about its endpoint. So for example, if we have this ray, and let's suppose that we have the point P, and that it extends through some point Q. If I take this ray and rotate it about its endpoint P, we might get something like this. And so there's the rotation. The rotation, that amount of rotation is what gives us the actual angle. And so let's put another point here on the ending side, the terminal side. We'll call it R. And let's talk about some terminology here. I would say that this side is the initial side of the angle. PQ, right? PQ is the initial side of the angle, and PR is the terminal side of the angle. And we have this angle. Now, we can name the angle many different ways. Given the letters, the symbols that I've already put up there, I could call the angle P. I could also write it using these symbols. That's not a less than. We'll use that in this context to mean angle. Since we have three different letters, I could call it angle R, P, Q. So that the endpoint, the P, is now the vertex of the angle. And so we can name it either by the vertex, angle P, or we can name it by three letters, angle RPQ. What's important is that the vertex must be the middle point, the middle letter, if we're naming it by three letters. And so I could also name it angle QPR. Now, if we could give the angle a name. And I could call the angle theta. Alright, so I just gave it a Greek name, and we will often denote our angles with Greek letters. So again, I could call it angle theta. Alright, so theta. And we have several different Greek letters, so here are some of the other Greek letters that we'll be using frequently in this course. Alpha, beta, gamma. I've already mentioned theta, and phi. So those are some of the Greek letters that we'll be using, and we may use our traditional English alphabet letters, but you should at least know these 5 Greek letters: alpha, beta, gamma, theta, phi. If I name any others, I'll be sure to be careful about mentioning them. Continuing on with angles, we can measure angles in a couple of different ways. But one thing we need to know first is, what do we mean by a positively and a negatively measured angle? So if we have these initial sides, so each of these will be an initial side, if I rotate the angle counterclockwise, if I rotate the ray counterclockwise, and I'll call this angle alpha, alpha is positively measured. So if we have a counterclockwise rotation, we have a positively measured angle. However, if we have an angle, let's say it does something like this. So I'll call this angle beta. So there's the angle beta. I would say that beta is negatively measured. So a clockwise rotation yields a negatively measured angle. Clockwise, negatively measured. Counterclockwise, positively measured. This is the convention that we will use in this course. Coterminal angles are angles that have the same terminal side. So for example, if I have let's say I have a positively measured angle that ends up here. All right, so there's my positively measured angle. Let me call it theta. And let's just say for argument's sake that I have a negatively measured angle that looks like this, phi. We can say that since they have the same terminal side, in this case I would have that theta and phi are coterminal angles. Alright, so they have the same terminal side. That's all that coterminal means. Note that they don't have to have one positive and one negative. We could have two positively measured angles that are coterminal. For example, if I drew an angle, let me draw an angle gamma, and it makes a full rotation and then has the same terminal side. I'll call that angle gamma. And then now theta, phi, and gamma are coterminal angles. As long as they have the same terminal side, coterminal angles. So you are likely familiar with the concept of a degree. And where it comes from is, basic idea is, if we have a complete revolution, if we make one full rotation, we will say that that is a 360 degree angle. So one full rotation is 360 degrees. So then a 1 degree angle, which I've shown over here on the right hand side, 1 degree then is equivalent to one 360th of a complete rotation. Alright, so a full rotation is 360 degrees, and then 1 degree is then 1 360th of a rotation. That's what we mean by a degree when we're talking about the measure of an angle. Alright, so let's work on that concept of the degree a little further. If we accept that a measure of 360 degrees represents one complete revolution, one complete rotation, then what part of a revolution or rotation does 90 degrees represent? Well, 90 degrees is what part of 360? Okay, so we can just write a fraction. 90 degrees out of 360 degrees, and we reduce the fraction using what we learned in, pre-algebra. 90 over 360 is 1/4 of a revolution. 1/4 of a revolution. Similarly, so a quarter way, if we think of that circle that we saw in the previous slide, 90 degrees is a quarter of the way around a circle. 180 degrees. 180 is out of 360. 180 divided by 360, that's the same as 1/2 revolution. And finally, 30 degrees. 30 out of 360. And again, if we reduce this, that's 1/12 of a revolution. So, understand that we can think of a measure, a degree measure, as part of a revolution. 1 degree is 1/360th, and so then 90 degrees is 90 360ths. And then we can reduce the fraction to get it into a more understandable fraction of the whole. A little bit of terminology now with the angle measures. If I draw this first angle, let me draw an angle here. Call it theta. In this example, I would say that theta is called an acute angle. So this angle, theta, is acute. An acute angle, the measure is between 0 degrees and 90 degrees. An acute angle measures between 0 and 90 degrees. And my second angle I'll call this phi. I've tried to draw this at exactly 90 degrees, and this would be a right angle. So the measure of angle phi is exactly 90 degrees. We will often see a little square drawn in the angle to denote the right angle. If an angle is greater than 90 degrees, but less than 180, I'll call this one alpha. Alpha is obtuse. And so then alpha is measures between 90 degrees and 180 degrees. And if we have an angle that's exactly 180 degrees, a full half rotation, I'll call this one beta, we see that beta is a straight angle. And so then beta measures exactly 180 degrees. So a little more terminology here. You should be familiar with what we mean by acute, right, obtuse, and straight as they relate to the measure of angles. A little more terminology. You probably learned about these terms in a geometry course. We say that two positive angles are complementary if the sum of their measures is 90 degrees, and we say that two positive angles are supplementary if the sum of their measures is 180 degrees. So in this diagram, you'll see that in the first picture, the first diagram for A, you'll see complementary angles. It does appear that these two angles together appear to form a right angle, a 90-degree angle. And so then alpha plus beta will measure 90 degrees. And so then if I said if alpha measured 25 degrees, then we could easily calculate the measure of beta. Then beta would equal 90 degrees minus 25 degrees, and that would equal 65 degrees. And in the second diagram, we see supplementary angles. Notice that they appear to form a straight angle. And so again, if alpha equals 25 degrees, then beta would equal 180 degrees minus 25 degrees, and so that would be 155 degrees. All right, so you should be familiar with the concepts of complementary and supplementary angles. Now, when talking about degree measures, there's actually two different ways that we can describe an angle with degrees. There's what's called decimal degrees and degrees, minutes, seconds. Most of the time we're going to use decimal degrees in this course, but I want to at least be familiar with degrees, minutes, seconds, because sometimes the angles that are shown in the textbook will have degrees, minutes, seconds, and so you need to at least be familiar with that. Be aware that I will never ask you to work with degrees, minutes, seconds, and degrees, decimals. I'll never ask you to exchange between them without a calculator. So decimal degree, often abbreviated DD, 24.5 degrees. Well, that means 24 degrees and 5/10 of a degree. All right, 5/10, 1/2. All right, so this means 24 full degrees and an additional half of a degree. That's what it means. That's what decimals have meant ever since you learned about decimals in 4th or 5th grade. Now, degrees, minutes, seconds takes a different point of view, and the idea being just like an hour. In an hour, there's 60 minutes. Well, now think of a degree. Think of a degree as being a whole, and we have 60 minutes in a degree. Similarly, each minute, if we think of the clock again, of our time system, each minute can be broken down into 60 seconds. Similarly, each minute of a degree can be broken down into 60 equal seconds. All right, and so what you'll see for this notation is you'll see something like, oops, that should be a D. All right, so we'll see some number of degrees and then some number of minutes, and then we'll see an apostrophe after minute, after the number of minutes, and then you'll see a double apostrophe after the number of seconds. So that's how we notate degrees, minutes, seconds. So if we consider that angle that we talked about just a moment ago, 24.5 degrees, then in terms of minutes, well, let's think about that. If there's 60 minutes in a degree, then 5/10, well, that's 1/2 of a degree. And so that would be the same as 30 minutes. So then 24.5 degrees is equivalent to 24 degrees, 30 minutes. 24.5 degrees is the same thing as 24 degrees, 30 minutes. All right, so here we have an angle measure, 5 degrees, 30 minutes, 45 seconds, and we wish to write it, we're asked to write this in decimal degrees. All right, so now let's think about this. We know that 30 minutes, all right, so we have 5 degrees, and then 30 minutes, well, that would be 30 out of 60 degrees. 45 seconds. Well, now wait a second. 45 seconds, there's 60 seconds in a minute and 60 minutes in an hour. So I would have to take that 45 seconds and divide that by 3,600 seconds in a degree. So we go through and we calculate this. Fortunately, I have a calculator here. All right, so if I take the 5 and I'll add to it 30 over 60 and add to that 45 over 3,600, and I'll enter, and I get 5.5125. .5125 degrees. Now, if we do have one of these graphing calculators, it can easily convert this for us. We just have to know what to do. Alright, so I've got my calculator. This is a TI-84 calculator. TI-83 works pretty much the same. First thing we want to do is check our mode. When you go to the mode, be sure that for now, on our mode, we have a choice between radians and degrees. We're going to talk about radians later in the course, but for right now we want our mode to be in degree. So move over to the degree and hit enter. Make sure it toggles over to degree. Let me quit back to my home screen. Alright, so what I'm going to do is I'm going to input 5 degrees, 30 minutes, 45 seconds, because this gets a little messy. I type in the 5. Now notice that the second function of the apps button has that angle above it. So hit second apps to bring up the angle menu, and there's degrees. And notice right below it there's the minute symbol. So 5, I hit enter to bring up the degree. 30, go back into the angle menu, bring up the minutes. And then I want 45 seconds. So type in the 45, and now, of course, they don't put that in the seconds. They don't put that in the same places where you found the other things with the angles. It's over here on the right above the plus sign. It looks like a quotation mark. So we have to hit alpha and the plus sign, and there is the the seconds. And now all we have to do is we've typed it in 5 degrees, 30 minutes, 45 seconds. Now hit enter. And it'll do that for us. But you should be able to do both of these. You should be able to understand that there's 60 minutes in a degree and 3,600 seconds in a degree to be able to convert. So now let's go back into the other direction. Suppose we have the 5.5125 degrees and we want that in degrees, minutes, seconds. Well, we know we have 5 degrees. And we know that the remainder, that 0.5125, I can think of that as a number of minutes. So what I'm going to do is I'm going to take that 0.5125 and I'm going to multiply it by 60. Since there's 60 minutes in a degree, I can take that part of the degree, multiply it by 60, and that'll give me a number of minutes. Alright, so go back to my calculator. Let's take that 0.5125, let's multiply that by 60. 30.75. So what that means is I now have 5 degrees, 30.75 minutes. But I don't want 0.75 minutes, I want an amount of seconds. So I'll do a similar process. I'll take that 5 degrees, 30 minutes, and then I'll take that 0.75 and multiply it again by 60 to determine the number of seconds. So I'll take that 0.75, multiply it by 60, 45 seconds. 5 degrees, 30 minutes, 45 seconds. Now again, calculator can do this for us. Alright, so I'll start off with the 5.5125 degrees. 5.5125. And what I will do is go back into my angle my angle menu, and go down to the 4th option, and you'll see that convert to DMS. right? That little triangle, DMS, degrees, minutes, seconds. Hit enter. It brings it up on my screen, and I'll hit enter again. 5 degrees, 30 minutes, 45 seconds. All right, so I want you to be familiar with what we mean by degrees, minutes, seconds versus decimal degree, and how to convert between them using either the tools on the calculator or just simple multiplications and divisions. Finally, let's talk about circumference and arc length for a circle. Now, hopefully in geometry, you learned that we can describe the circumference of a circle and can be written in terms of the radius of the circle. So let's be sure we understand some terminology here. When we talk about the radius of a circle, the radius is a distance from the center of the circle to the edge of the circle. That's the radius. A diameter goes from edge to edge through the center. And so you might remember that the diameter, the measure of the diameter, is twice that of the radius. Let me use lowercase letters here. The diameter is twice the radius. The circumference is a measure of the distance around the circle. And we've learned somewhere in the past that we can describe the circumference as 2 pi times the radius. Now, if we have the diameter, right, notice that we have that 2 pi, that 2r, and notice that 2r is equal to the diameter. We can also describe the circumference as circumference is pi times the diameter. Again, a little bit of terminology here. So let's consider this diagram. Here, P is the center of a circle, and we have a positive angle, RPQ, is said to be a central angle that is subtended by an arc, RQ. All right, central angle. So P is the center of the circle. It can then form a central angle of the circle. And so then we have this angle RPQ as we've described before. So now just it's inset in a circle rather than being two rays. And what we see here is we have this arc RQ. So this arc right here, RQ. And notice that the arc RQ is a part of the circumference. If we think of the circumference as the full distance around, then this arc RQ is some portion of it. So now here's an exercise that we could maybe work on related to this. All right, so we have, let's consider this same diagram, and now let's let the radius measure 6 inches. All right, so the radius measures 6 inches. And the angle RPQ measures 30 degrees. And the question is, find the measure of the arc RQ. What's the measure of that arc? Well, I know the circumference, right? I know that the circumference is 2 pi times the radius, and so that would be 2 pi times 6 inches. And so that would be 12 inches. Sorry, it's not 12 inches, it's 12 pi inches. 30 degrees, recall from earlier that 30 degrees out of 360 degrees, that's 1/12 of a rotation. 1/12 of a revolution. So then the measure of the arc RQ, should be 1/12 of the circumference, or 1/12 of 12 pi, or more simply, pi pi inches. So basically what I did there is to find that measure of the arc, I can think of it as a portion of the circumference. The angle measure tells me what portion of the circumference to use, and I can calculate the circumference by using the fact that the circumference is 2 pi times the radius. Now, there is a nice little formula that we can use for this. There is a relation between the circumference and the arc length. And in general, the relationship between the measure of the central angle, which we're calling theta, the measure of the circumference, which we're calling c, and the measure of the subtended arc, s, can be expressed with this proportion. And so basically what I did, if you look at this proportion, theta is to 360 degrees as s, remember that's the arc length, is to c, the circumference. And notice basically what I did was I multiplied both sides by c. And so I found that the arc length s was theta over 360 degrees times the circumference. The portion of the circle, right, the amount of rotation times the circumference. So you can use the proportion, or you can use thinking of it as a part of the circumference. Either way works. Let's see one more example. How large an arc is subtended by a central angle of 50.73 degrees on a circle with radius 5 meters? How large an arc? All right, so let's now problem solving. How large an arc is subtended? We want S. Right, if we're thinking about that diagram on the previous slide, we want S by a central angle of 50.73 degrees, theta, on a circle with radius 5 meters. Oh, wait a second. If we think of our formula on the previous slide, it told us that theta was to 360 degrees as S was to C. We need the circumference. Well, just remember that then the circumference is 2 pi times the radius. All right, if we aren't told the circumference, then we have to figure it out. So then let's fill in what we know. Theta, 50.73 degrees over 360 degrees is equal to S. We don't know S, over 2 pi times 5 meters. So then, solving for S, we would have S equals, multiplying through by 2 pi times 5 meters, that's 10 meters. So I'd have 50.73 degrees over 360 degrees, and I'd have to multiply that by 10 pi meters. All right, so let's bring up our calculator. And let me bring it over here so we can easily see the calculation. All right, 50.73 degrees divided by 360 degrees. The degrees will drop out there. Give us a unitless number, 50.73. Divide that by 360. And so that gives us 0.1409. So that's the amount of rotation. Right? That angle is 0.1409 of a full rotation. And then I'd have to multiply that number, take that number, that answer, and multiply it by 10 pi. Oh, and to bring up the pi, hit second and the exponent key. And we'll hit enter. And so then we'll just go to 2 decimal places here, 4.43. So the The arc length is approximately 4.43 meters. All right, that concludes this presentation.